Hello everyone, my name is Ali Ayub and I'll be presenting my dissertation research titled Continual Learning of Visual Concepts for Assistive Robots Through Limited Supervision, and it is under the supervision of Dr. Alan R. Regner. So people with disabilities and elderly require assistance to perform everyday tasks in their daily lives. However, it is difficult for people to be around 24/7 to provide assistance. Especially with the COVID-19 pandemic and social distancing rules, it is even more difficult for people to be around. So in these precedented times, assistive robots are necessary to provide assistance to people in everyday lives with tasks like feeding or shaving or even loading their dishwasher. Now, one of the first capabilities that an assistive robot must have is to be able to understand its environment and the preferences of its users. So, for example, in this environment, if a robot is asked to move the utensils from the table, it must understand the object in the environment and the context of the environment. Similarly, in this picture, the robot must be able to understand the preferences of the users and the environment to be able to move around and provide assistance with different tasks. Real-world environments, however, are dynamic and change over time, and even our preferences would change over time. So, for example, you might change your kitchen from this to this, or change the utensils in the kitchen from this to this set. The robots now have to adapt to these changes, and usually there is not a lot of supervised data available to the robots to adapt. So the research question that I try to answer in this research is, how can we create assistive robots that learn novel concepts continually from a few examples? And the research question leads to a couple of supplementary questions. First is, how can I create a computational model that can allow robots to learn concepts continually from a few examples? And secondly, how can this method then allow robots to perform real-world applications, such as assisting people with different tasks? Now, to create a computational model, I draw inspiration from cognitive science and how the human brain learns different concepts. Now, inspired by the concept learning process, my model first receives a new object as a stimulus and finds the difference of the object from the previously learned concepts. Now, if the object is closer to one of the previously learned concepts, the closer concept is updated using the new object, and this process is termed as memory integration in the cognitive science literature. Now, if the new object is quite different from the previously learned concept, the model performs pattern separation, in which a new concept is generated, initialized with the new object. And this whole process continues over time when the model gets new objects. Now, to evaluate our approach, we tested it on a benchmark dataset against state-of-the-art approaches for recognizing objects after learning them continually. Our approach, CBCL, outperformed state-of-the-art approaches by significant margins in terms of classification and accuracy for recognizing different objects. We then applied our model on real-world assistive robotics applications on different robots. First, we taught a Baxter robot to learn different objects and their contextual information, so that the robot can then recognize out of the context objects and then move them to their correct context. So in this case, move the soap to the correct context in the bathroom. We then applied the robot for a cleaning application where it can recognize objects that it should clean on a table and then move them to their correct place. After the object recognition task, we then applied our model on a pepper robot to wander around in different environments at Penn State and learn those different contexts. Now, this task was much more challenging because environments belonging to the same category could be very different, and the images were quite blurry because of the camera movement on Pepper's head. After learning the environments, Pepper was also taught the norms attached to these different contexts. So for example, it learned that in a library, it shouldn't talk loudly, or when in a bathroom, it shouldn't record the video of people who were in the bathroom. So revisiting the research questions, we developed a computational model that allows robots to learn novel concepts continually using only a few examples. And we also showed that our model then allows robots to perform real-world assistive robotics applications. Thank you. And if you have any questions, please let me know.